Okay, so let's try quotient rule for the first one, sine x over x squared. Oh, everybody okay? Okay, so for this one, it's going to be the derivative of the top, which is cosine, times the bottom. Take away the top times the derivative of the bottom. And it's all over the bottom squared, which would be x to the 4. Okay, so this one, we could do a little simplifying real easy. So for example, everybody here has an x in them. So with at least one x, I could rewrite this as cosine x. Well, put it in the front. Minus 2 sine x. And there'd be an x cubed here. Okay, so everybody lost one x. I factored it out. That's pretty reasonable, I think, to expect you to simplify. The next one, however, there is a little trick here that you can do, and I think you'll all see what I mean, where sometimes it makes sense to simplify because it would be easier to take the derivative. There's no simplification, I think, that we get out of this initially, but why don't we take the derivative and we'll see what happens. So the derivative of the top will be 2 cos x times 1 plus cos x. I guess I really shouldn't put an equal sign there. They're not really equal. And then I'm going to take away, and I'm totally going to run out of space here. My apologies. Got to plan ahead a little better, Mr. Joyce. Need more space, so it'll be 2 cos x, 1 plus cos x. Then take away the derivative of the bottom, which is negative sine, times 2 sine x. Okay. And the bottom squared will give me now the full quotient rule finished. But the thing is, it may not be obvious looking at it, but when you get to trig especially, remember there's tons of identities in there. So let's see what happens, and we'll see if we recognize anything by expanding this out. This would be 2 cos x plus 2 cos x squared. Then negative negative would be positive. So it would be positive sine x squared, or sine squared x rather. And it would be divided by 1 plus cosine x. So does anybody notice an identity that might make life a little easier? Yeah, there's the sine squared plus cos squared, right? That equals to 1. So I have 2 of those. That means this whole thing would be equal to 2. Right? Now I'll show you this. This is the reason why, as I was saying, that'll be 2 cos x plus 2 over 1 plus cos x squared. If I factored that out, then I would be able to remove it from the top and lose 1 on the bottom. So now, I do think this one's simpler. I'm running out of space here, but I do think this one is worth it. It would now be 2 over 1 plus cosine x. And that to me is way better than what I had initially for the derivative. Okay. And again, if I had to take the second derivative, that's a way easier second derivative there than what we had initially. So after product and quotient rule, the next topic wasn't that long ago. Chain rule. Oh, did I skip some? Yeah, sorry. DJ's paying attention. I'm not. But you guys were right. It was chain rule that was next. But I forgot about, we talked about higher derivatives. So in this instance, 4 sine x minus 5 cos x. If I'm going to find the second derivative, first I got to know the first derivative. So the first derivative hopefully this derivative is basic enough that we can just whip through it. It would be 4 cos x minus 5 times negative sine x. So that's the same thing as 4 cos x plus 5 sine x. So if I want the second derivative, that means I have to take the derivative of the derivative. Okay, so this time, this is the piece I'm going to be taking the derivative of. 4 cos x, that'll be 4 times negative sine x. And 5 sine x will become 5 cos x. Okay, so I guess I could tidy this up a little bit. Negative 4 sine x plus 5 cos x. So this would be my second derivative here. Oops, did I not say that again? Which one should be minus? I think that's okay because here it's positive sine, so it'll be positive cos here. Yeah. So we talked about 2 specific applications of higher derivatives. So does anybody remember what those applications were? Stole it from you. Yeah, it was velocity and acceleration. So I'm expecting that, as I said, that's the most common one that we'll look at. And I'm expecting that if I asked you for velocity, you'd know that's the first derivative. And if I asked you for acceleration, that would be the second derivative. Okay, so if maybe somewhere in your notes you may want to remind yourself velocity is the first derivative and acceleration is the second derivative. Okay. So the last topic in review was the chain rule. So I'm going to walk you through a couple of these. I think chain rule went pretty well after we spent 3 days with it. You may not need to, but I usually rewrite these things. I usually rewrite it as an exponent so that way I can see the power rule more clearly. So that's the outside function's derivative. That is the inside function's derivative. And same thing if I do the next one. Outside function's derivative and the inside function's derivative. So remember, just in case I go too quickly here, that's like x to the negative 1. So I'm going to rewrite this as 1 over x subtracting 1 over x squared. Okay. I'm gonna skip this next one just for a second here. When it comes to natural log, the first thing you should be thinking about is how do I avoid all those quotient rules, product rules, and chain rules. Well, I can use log laws to separate that whole thing out as much as possible. That means if I want to find the derivative, I just need to remember that it's the reciprocal. So this is actually a pretty simple question thanks to the fact that there's a logarithm in there. Okay. So for the next one, I'd like you to try it, and I would like you to make your best attempt at simplifying the one that remains there. Okay, so give that one a shot and give your best attempt at simplifying it. Okay, so it looks like some people had some strategy involved. Let me just see, hands up, how many people did quotient rule? So I'll let you know quotient rule works. It's the way I've done this question before too, but your algebra tends to be harder when you simplify. Anybody use product rule? So we're about half and half. So I'm going to go the product rule way just so, again, you know, you're thinking about strategy when you do these questions. If I did product rule on this, there's 2 functions. It's the derivative of the first piece times the second plus the first piece times the derivative of the other one here, which is going to be negative 1/2 times x squared plus 1. This will be negative 3/2 now, and there will be a 2x for the derivative of the inside. So I'm going to try to simplify this as much as I can, and part of that is going to involve fractions, so I'm going to show you the fractions that I'm going to work with. This would be 3 over the square root of x squared plus 1. If I look at all these pieces here, that 2 and that 2 would disappear, and I've got a couple of x's, so I would be able to call this negative 3x squared on the top, and x squared plus 1 to the 3/2 on the bottom. So in order to have everybody catch up, this piece here, this is like the exponent 1/2, and this one has 3/2. So to make a common denominator, I would need to multiply in an x squared plus 1. So that would be 3x squared plus 1 over okay, and now I have a common denominator. I have a 1/2 here, and I have a 1 here. So 1 1/2 is the same as 3/2, so I have a common denominator. Okay. So finally what I'll end up with, once the common denominator is there, is 3x squared plus 3. Take away 3x squared. And as I said, the exponent now is 3/2. So that would disappear, and that would disappear, and the simplest form I could write this in would be like that. Okay, now I realize that's quite a marathon to do all of that, but what we really did was find a common denominator. If you did quotient rule, you would get the same simplified answer if you also found a common denominator. So, you know, as I said, I realize that's more algebra knowledge than calculus knowledge, but you know, I'm still expecting you to be able to simplify. I'm just not going to force you to simplify all of your work.
What level of terror is the test going to be like in terms of this? Like,